My dear students, welcome to Pathfinder. So today I came with the second part of this electrostatics. So we'll be discussing some questions on electric potentials and capacitance. So let's start with our question. Okay. So first question for the day is a thin spherical cell is charged by some source. The potential difference between 2 points C and P in voltage shown in the figure is. So we have to find the potential difference between the point C and P. So see, this some charge is given to this pair. So this pair having some charges. So of course, so we have to find out here potential and here potential. This potential difference we have to find out. And that question came in 2024, latest question. So very easy question. So we know that for a cell or hollow sphere, if we bring any charge from unit charge, 1 unit charge, Q equal to 1 unit. If we bring 1 unit charge from infinite to a point, so whatever this work done will be doing, so this work done is equal to potential at that point. So from there we know this potential on the surface is V surface is equal to 1 by 4 pi epsilon naught Q by R, where R is the distance from the center of this sphere and Q is the charge has given to this sphere. So you know this formula. So from there we will get that at the center point, at that surface point potential or work done to bring in unit charge from infinite to that point is 1 by 4 pi epsilon naught Q by R. So if we bring same charge from unit charge from infinite to that point, whatever work done will be do, so will be same work done to bring infinite to that center. That means that potential at that center means BC and this one is VP we have. So that should be same. And one more thing we have done, we have plotted that V versus R for a cell, it was like this. So that means this point was small r equal to capital R. At the surface, up to surface, that potential is V naught, where V naught is this value. So center to R distance, capital R distance, up to this distance, potential will remain same because same work done we are doing to bring from infinite to that point. So of course that potential difference delta V should be equal to Vp minus Vc, which is equal to 0. Okay, so this is the one of the simplest question. So latest question. So we'll be going for the next question. The option should be fourth option. So we'll go for the next question. This one also from 2024 NEET. So in the following circuit, the equivalent capacitance between terminal A and the terminal B. So we have to find that point A and B, what will be the equivalent capacitance. So for this one, we have to see that how that circuit looks like. It is looking like, see that it's looking like Wheatstone bridge or symmetric circuit. So this ratio of these two capacitance is equal to ratio of these two capacitance. If we take this one is C1 and this one is C2, C3, C4 and this one is C5, then Wheatstone bridge formula was like this. We are having C1 by C2, C3 by C4. If they follow this rule, then this capacitance we can neglect this one. So that means now we are having that equivalent circuit will become A point is here and we are having one capacitor having 2 microfarad here, and one more capacitor 2 microfarad here. See, they are symmetric because this 2 ratio will get 1 and this 2 ratio will get 1. That is, this formula is followed by this diagram. So now we can take here one more. This is our B point. and this one also 2 microfarad, and this one also 2 microfarad. So now we'll see that these two capacitors are in series and these two are in series. So finally we'll get that series combination we know. So this 2 will be gives us 2 into 2 by 2 plus 2, which is equal to 4 by 4, which is equal to 1 microfarad. So we'll have here 1 microfarad, and this 2 also gives you 1 microfarad. Both are having same value. So we are having two 1 microfarad capacitors which are connected in parallel. It looks like parallel. See, these two are parallel now. So this one also 1 microfarad, and this is our B point and this is our A point. So now equivalent capacitance for parallel combination is C equal to C1 plus C2, and for series we have used that C equal to C1 C2 by C1 plus C2. This formula we have used because 1 by C is equal to 1 by C1 plus 1 by C2. By using this formula we got this one. So now here these two are parallel, so they will be added. So now equivalent capacitance, net capacitance will become, so C1 is 1 microfarad and this one also 1 microfarad. Finally we are having 2 microfarad. So this is the equivalent capacitance between A and B. So our option is first option. So let's go to this next question. Okay. So this question also just a recent question. Okay. See. So given below are the two statements. One is labeled as assertion, another one is labeled as reason. Assertion, what they said? The potential V at any axial point at 2-meter distance R from the center of the dipole of a dipole moment P vector of magnitude 4 into 10 power minus 6 coulomb meter. So this one is given, dipole moment, P vector is magnitude is given this one, and potential is given this one. So let's see the diagram. So we have a dipole, means here we have a dipole. Anyone we can take negative charge Q, and this one we can take positive charge, and they are separated by 2L distance from center point, and this is our point P point where we have to find potential. So at that point potential they have given 9 into 10 power minus 3, plus minus they have given. So both side we are having, if you take the distance, that side also will get negative and that side will get positive. So potential will get that formula for dipole from r distance. That potential formula is, we know this, first we will be taking minus q charge, what will be the potential here? For plus q charge, what will be the potential here? So now we will be adding these two potential and finally we will get that formula. That potential is 1 by 4 pi epsilon naught. For axial point it will be P, magnitude of P by r square. So now this is the formula. So let's check that formula and we'll find that this potential or not. Then we'll say that this one is correct. And of course that reason they said that V equal to 2P by 4 pi epsilon naught r square. See, the formula is exactly P by r square. So how we'll get the P by r square? For positive charge, we'll get V positive is equal to 1 by 4 pi epsilon naught Q by r. See, the distance from positive charge, this distance becomes r minus L. This one. So this will be r minus L. For negative charge, potential will be, as well as we are having the constant term 1 by 4 pi epsilon naught. Q by, so here we have that R plus L, because this distance is now R plus L. See, this one, R plus L. So now we'll get that potential, net potential is equal to this one by calculation, and approximation distance we will be taking that R is far greater than L, then we'll get this formula. So by combining this one, so potential we'll get this one. Of course, this reason is incorrect, first we get, and let's check that assertion is correct or not. So for getting this one, we'll put that 4 pi epsilon naught equal to 9 into 10 power 9 into p value is given 4 into 10 power minus 6. So we'll be putting 4 into 10 power minus 6. Okay. See, that was a negative charge. So of course, you have to put this sign also there, and this R is equal to given. So here 2 meter. So it is 2 square. 2 square is 4. So we'll be calculating that 4 and this 4 will get cancelled. So finally we'll get 9 into 10 power 9 minus 6 is 10 power 3. So we'll get volt. See, this one is correct. So we have to choose the right option. So both A and R are true. So this one is the wrong. So both A and R true is okay. Sorry. A is true but R is false. This one also false because formula is incorrect here. So A is true but R is false. So this one is the right answer. So third number will be the right answer. So we'll go to the next question. If you want, you can take screenshot of this video, then we'll go further. Okay, chalo, let's go. Okay, this is the question here. So which came in mains 2020. See, the effective capacitance of a parallel combination of two capacitors C1 and C2 is 10 microfarad. So we'll read that line and we'll be writing according to question. So first they said effective capacitance for parallel combination, they said. So two capacitors which are having C1 and C2 is given 10 microfarad. That means parallel combination effective capacitance is C1 plus C2, we know, which is given here 10 microfarad. The first equation we got. Then they said when these capacitors are individually connected to a voltage source of 1 volt. So individually means one capacitor C1 we have kept with a voltage source 1 volt. So how many charge or how many energy stored we will be calculating. The energy stored in the capacitor C2 is, they said, energy stored in the capacitors E2 we are writing is, they said, 4 times that C1. That means energy stored in first capacitor. So energy stored here E1. So similarly we have taken C2 capacitor where energy stored is E2. Same 1 volt we have connected. So now according to question we are having this one. So we know this energy stored in that capacitor is E equal to 1 by 2 CV square. Okay. So we'll using this formula. So E2 is equal to 1 by 2 C2 into V is 1. So 1 square. Similarly 4 times into 1 by 2 C2, sorry C1 here, into 1 square. So first term 1 by 2 will cancel, and then this 1 square is 1, that will not bother you. So that means we will get C2 equal to 4 C1. So this is our second equation, and this one we are having first equation. So by solving these two equations, we'll get that C1 and C2 value. Chalo, let's find. So C1 plus C2 value is 4C1. So 4C1, that is equal to 10 microfarad. So that means 5C1 equal to, so 10 microfarad. So C1 equal to 2 microfarad. So similarly C2 will get 4 into 2, 8 microfarad. Okay. So now let's go to this question. So if these capacitors are connected in series, their effective capacitance will be. So if these two capacitors are connected in series, so what will be the effective capacitance value? So effective capacitance or C equivalent will get. So for series combination, we have used previous questions C1 C2 by C1 plus C2. So we'll put these values 2 8, 2 8 and 2 8. So 2 8 into, okay, so 2 8 is our 16 by 10, which is equal to 1 by 6 microfarad. So we are having in unit of microfarad, so we'll get in microfarad unit. So this will be the answer, 1.6 microfarad. So next we will go to this next question. Okay. Okay, chalo. So a parallel plate capacitor has plates of area A, okay, separated by distance D between them. It is filled with a dielectric. Okay, we have inserted one dielectric which has a dielectric constant that varies as K of x equal to K into 1 plus alpha x. Here this one is the dielectric constant and this K value is constant in the question they said. Okay, and x is the distance and alpha is the constant part. This one constant, this one constant. So the x is the distance measured from the one of the plates. If alpha d is much more less than 1, the total capacitance of the system best given by the expression. Okay, that question came in 2020 in mains. So we'll be finding that capacitance value. So we are having these two plates. Let's draw the diagram. And in between two plates, we have one dielectric. So these plates, we have dielectric filled with this one. So let's say this one is dielectric permittivity of this medium is epsilon. So we know this epsilon equal to epsilon r into epsilon naught, or we can say epsilon naught is our dielectric constant into epsilon naught. And the plate separation is d, they have given, and area is A. So for this case, once you see that K is not constant here. So since that K is not constant, we have to consider in a such a way. So we have to take this dielectric and this side we have two plates. So from x distance, we have to consider one ds thickness. So we have to consider one dx thickness. So this is our dx thickness. So dx is too much small, so that we can say that this point to this point does not vary too much dielectric. So now what will be the capacitance of this part? So this part capacitance will be, so you can say that dc equal to A epsilon by d. Okay, so for parallel plate capacitors we know this A epsilon by d value we know. So now, so A is same, see that plate area and that plate area same, so we are having A, and epsilon becomes that one K epsilon naught, K epsilon naught. and d distance becomes, this two distance becomes now dx. So this is the capacitance value of this annular dx thickness part. So you can see that so many dx thickness capacitors are there. They are just kept one by one. That means they are in series. So equivalent capacitance will be, so 1 by C equivalent will get 1 by C equivalent will get integration 1 by Ci, Ci or dc we can say. So let's find out C equivalent part. So 1 by C equivalent, let's say 1 by C is equal to integration. So we have to put that dc is dx by a epsilon naught, and k value is given here, capital K into 1 plus alpha x, capital K into 1 plus alpha x. So now we see that we are integrating with respect to x. That means x, we can say x start from here, so x equal to 0, and x will go up to x equal to d. So integration limit will be 0 to d. Thickness is d. So this thickness x equal to 0 to x equal to d. So see that part, constant part will be taking out from this integration. So that will be 1 by a epsilon naught into k, and integration dx by 1 plus alpha x and 0 to dx, sorry, 0 to d. So now some student can know that formula, direct formula someone can use, and if you forget the formula, we have to remember once that we know that we have to consider that 1 plus alpha x equal to t. So we can take 1 plus alpha x equal to t, then we differentiate this one differentiation will get 0, and this part will get alpha into dx equal to dt. When we will be using that substitution rule, we have to change that limit also. So x and t, when x equal to 0, so we put that x equal to 0 part, so t equal to 1. When x equal to d, so that will be, so x equal to d, t will become, so 1 plus d into alpha. So t will become 1 plus d alpha. Wait. 1 plus d alpha. Okay. So now we'll put these values like this: 1 by a epsilon naught k into integration limit 1 to 1 plus d alpha. Okay. So now that will become dt by, and this one we have taken t. So of course integration dx by x is logarithm of x or ln x. So we'll have that 1 by a epsilon naught k, and this one is ln t. So limit is 1, and this one is 1 plus d alpha. So finally we'll get 1 by c equivalent equal to 1 by a epsilon naught into k and ln, first upper limit by lower limit we can put 1 plus alpha d by 1. This one will get. So 1 plus alpha d by 1 is 1 plus alpha d, and we can put this one 1 by c equivalent equal to 1 by a epsilon naught into k into log of this one. So we can see this one is, we can put this value, so log of, acha, ln 1 plus alpha d. So we can now expand that C equivalent value now. C equivalent is C equivalent equal to A epsilon naught K by ln 1 plus alpha d. Okay. Wait, one thing we have forget here. Alpha dx equal to dt. So we have changed when integration. So dx equal to dt by alpha. So the dt by alpha should be there. So when we have put here, one more alpha will come here. So one more alpha will have to put. So alpha will be here. So now we know this expansion, logarithm expansion is we can put here ln 1 plus x equal to x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and plus so on. It will be keep continuing when x is much more greater than less than 1. So that is given in the question only. So much more, so x is our alpha d, which is much more smaller than the 1. So we can neglect this higher order term. So finally we will be using this two term only. So you can take here approximated value is A epsilon naught K alpha by d value is our x minus x square by 2. So x is alpha d. So alpha d minus alpha square d square by 2. So we have used these two terms x equal to alpha d. So from there we can take alpha d common. So A epsilon naught K alpha by alpha d will be taking common. From there we will get 1 minus alpha d by 2. So again alpha 1 alpha will get cancelled. So finally we will get that C equal to A epsilon naught K by d into 1 minus alpha d by 2 inverse. So again we can expand this one, binomial expansion. And binomial expansion is we are having 1 plus x power n equal to 1 plus nx plus n into n minus 1 by factorial to x square. It will keep going like this. So by using this one we will get that n equal to minus 1 and here this minus sign we have. So x equal to minus alpha d by 2. So if we put this value and we will neglect the higher order term, so this order term will be neglecting. So finally we will get 1 plus n value is minus 1 and x value is minus alpha d by 2. So finally this minus and this minus gives us positive sign. So that will become 1 plus alpha d by 2. So we will get the C equivalent equal to A epsilon naught K by d into 1 plus alpha d by 2. Okay. So let's check that answer. Which one will be the answer? So A epsilon naught K by d, every term we have. So 1 plus alpha d by 2. So we are having this part, second option. Okay. So let's come to this next question. Okay. So this question also from 2019. So parallel plate capacitor has 1 microfarad capacitance. One of its two plates is given charge 2 microcoulomb. So two parallel plates we have. So these two parallel plates makes one capacitor. So that capacitance value is 1 microfarad, and one of its two plates is given 2 microcoulomb. So let's say this one is Q1 equal to 2 microcoulomb, and another one is 4 microcoulomb. So we'll get that Q2 equal to 4 microcoulomb. So these two plates here positive charge. So this plates having 2 microcoulomb. So here also positive charge. They said according to question, this one is 4 microcoulomb. Okay. So now the question is, the potential difference developed across the capacitor is, what will be the potential difference between these two plates? Sorry, distance is d, so potential difference is how much? So to calculate this one, we'll check that first we know for any plate what will be the electric field intensity inside this one. Here electric field intensity how much? So from there we can find out potential, because we know that potential and electric field intensity relation. So for any plate, so for conducting plate, so we know this electric field intensity E value is sigma by 2 epsilon. We know this for conducting plate, E naught is E equal to sigma by 2 epsilon naught. So for net electric field intensity will become, so of course we are having that this side more charge, so electric field intensity will be in this direction, right? Because this side we have more charge. So of course Q2 will be here greater value. So that means E2 will be greater value compared to E1. So that means sigma 2 by 2 epsilon naught minus sigma 1 by 2 epsilon naught. 1 second. So this one, okay. So now sigma 2 is equal to, sigma is the charge per unit area. So here area is same both plates because they are parallel plates. So we can get this sigma 2 equal to Q2 by A2 into 2 epsilon naught minus sigma 1 is Q1 by A1 and into 2 epsilon naught. Okay. So finally we will be taking that common part. The common part is A1 A2 is equal, so we can put this A value here only. So if we put here A value, A1 equal to A2, so let's take it as A. So that common part is 1 by A into 2 epsilon naught, and finally Q2 minus Q1. So this one is your net electric field, and we know this electric field intensity and potential. So potential is E into distance. Let's say this distance between these two plates is D. So E into D. So we'll get that finally E value is 1 by 2A epsilon naught and Q2 minus Q1 into D. So finally you will get that. So this Q2 minus Q1, we can put this values, see that they have given, and 2 micro, one is Q2 is 4 microfarad, 2 microfarad. So finally we will get that 1 by 2A epsilon naught, or we can take here D, this distance D value, and Q2 is 4 minus 2 microfarad is 10 power minus 6. So finally we will get that V equal to, so D by 2A epsilon naught, and 4 minus 2 is 2 into 10 power minus 6. So this volt will get. So now these two get cancelled. Once you see, this is equal to A epsilon naught by D. So C equal to A epsilon naught by D is the capacitance value of these parallel plates. So we can put this value A epsilon by D, that means 1 by C, this one, into 10 power minus 6 volt. So we'll put that C value now. So C value is given here in that question. So C value is given here 1 microfarad. 1 microfarad is 10 power minus 6 farad equal to 10 power minus 6 the volt. So this one cancel. So finally answer will be 1 volt. Okay. So answer will be 1 volt. And thank you everyone. Let's see you in the next video.